To combine these radicals, we need to really split up each radical over each unique base. So the x's, the y's, and then combine them from there. So this is the square root. That's the same thing as a power of 1/2. So this first one is xy cubed to the power of 1/2. And that can distribute into both of the powers. X is a power of 1, y is a power of 3. You're going to multiply them in there. The same kind of process for the second one. X squared y, this is to the power of, well, this is a cube root. That's the same thing as a 1/3 power. Always the power of the radical goes in the denominator of the power. So distribute that into there, we get a y to the 1, distribute into powers, and multiply it through. So we're going to get x to the 1/2 times y to the 3/2. That comes from this first one here. And then times by x to the 2/3, y to the 1/3. Rearranging this, x to the 1/2 times x to the 2/3, y to the 3/2 times y to the 1/3. Multiplying like bases, we need to add the exponents, and we need to get common denominators. So I'm going to make this a denominator of 6, so I'm going to multiply by 3/3. So we're going to get x to the 3/3. I'm going to add that to, sorry, it's 6/6. I multiplied by 3/3. That gives me 3/6. I did multiply this by 3, multiply this by 3, multiply this by 2, gives me 4/6, times by y to the power of, once again, I need a base of 6 here, or a common denominator of 6. Multiply by 3/3, so give me 9/6 plus 2/2 here becomes 2/6. And that's going to give me x to the power of 7/6, y to the power of 11/6. There's a couple ways I can write this. So I can write these as mixed numbers if I want, and that can show me that there are full powers of 6 in there that I can actually take out of the radical. Because what this is essentially is the 6th root of x to the 7 times y to the 11. Again, the numerators are the power, and the denominators, they're both the same actually, so it's just the 6th root. And you can see that I can take a 6 x's out of here as like this, times x to the 6th times x to the 7th. And the same thing can work for y to the 6th, and this is the 6th root here, and y to the 5. 6 plus 5 is 11. So what this ends up giving me is x from this one, and then the 6th root of x. And then here I get y, and then the 6th root of y to the 5th. Which then I can finally write as xy, the 6th root of xy to the 5th. And that's one of the ways you can write this answer. There's probably a few different ways that it's valid, but this might be what they're looking for.